right, so solving log equations is very similar to solving exponential equations. We're going to end up with an equation that's got a logarithm in it. We're going to try to get the thing with the log by itself. We're going to isolate the logarithm, and then we're going to convert the equation into exponential form. And again, we do that for the same reason we take a cube root of a cube. They are inverse operations. Likewise, logarithms and exponentials are inverse operations. They undo each other. All right, so I've got our triangle there again. We're going to make use of that as well. Let's give one of these a try. All right, so I've got 4 plus log base 2 of 9x is equal to 2. And the logarithm that we're going to try to isolate is right there. So I need to get rid of the 4. The 4 is attached by addition, so I'm going to subtract 4 from both sides, which leaves me with log base 2 of 9x equals -2. All right, so let's set up our triangle. Okay, the base of my logarithm is 2. That goes on the bottom left. What's in the logarithm goes on the bottom right. And the logarithm is equal to the exponent on top. All right, so there's my log-dan converted to a DNA. And let's write that as an exponential equation. So it's going to be 2 to the -2 equals 9x. All right. It's not going to be too hard to solve, but let's think about 2 to the -2. That's actually 1 over 2 squared, which is 1/4. So I've got 1/4 equals 9x. And all I have to do to solve for x is to divide by 9 on both sides. I do have to be careful here, though, because now I'm dividing fractions. So I'm going to think about this fraction down here as 9 over 1. So that I can do keep, change, flip, or however you learned to divide fractions. So I grew up in Texas, and we learned when dividing fractions, don't be shy, flip the second and multiply, which is a little bit catchier than keep, change, flip, but whatever works, right? So we're going to take 1/4, I'm going to flip the second one over, 1/9 equals x, and x is going to be equal to 1 over 36. And that's all there is to it. All right, let's try one more. All right, so here we have an equation where the logarithm is already isolated. Log of 3x minus 1 equals 2/2. So we're actually ready to convert this to an exponential equation. All right, so when I draw my triangle, let's see, the bottom left of my triangle is supposed to be the base of the logarithm. So this one, we have to remember that a log without a base means log base 10. So that's the number that's going to go in the bottom left. The bottom right is the argument of the log. And then the logarithm is equal to the exponent. So the 1/2 is going to go up top. All right, so let's write that down as a DNA exponential equation. So we're going to have 10 to the 1/2 equals 3x minus 1. All right. And 10 to the 1/2, remember that's actually a radical. The denominator of the exponent tells you what kind of root it is. It's a square root. So we don't have to write the 2 in the little crook. You can if you want to. And then we'll have 10 to the first power inside, or just leave it as square root of 10, equals 3x minus 1. And now just focus in on the 3x minus 1 on the right. We're going to add 1 to both sides. So I get the square root of 10 plus 1 equals 3x. Don't make that the square root of 11. The 10 is inside the square root. The 1 is outside the square root. So we're just going to leave it as root 10 plus 1. And then we're going to divide both sides by 3. And that gives me root 10 plus 1 divided by 3 is equal to x. All right. So very straightforward. Exponential functions, exponential equations, we convert to log form. Log equations, we convert to exponential form. The only thing that gets tricky is when we have more than one logarithmic term in an equation, and we're going to talk about how to deal with that when we have class. See you there.